simplifying algebraic expressions. So we know the expressions just means there's no equal sign, yeah? So we don't have to worry too much about, like, when they say expression, just go on with normal. And algebraic just means we've got the letters and the numbers, yeah? Just a way to say that. And simplifying just means we're trying to make it into a smaller thing or group things that are like terms. So this is where we need to know what a like term is. So a like term have the exact same pronumeral. What was pronumeral again? What did that mean, Joey?
A little.
Good, thank you. So it's the exact same letter in it, including or they can have including powers. So for example here, this 3x is similar to 7x because they both have that x. They both have the same letter. Now we're saying the next terms here, these two terms are similar, and it's because the letters look the same. So this x squared y is the same in both. So they're like terms if the letters look exactly the same, okay? So when they are the like terms, it means you can add them together. So they've got here, if you have 5x plus 7x, you can add them because they're both x's, and you just say you have 12 of them. So if you think of them, they're like a group of things. So if you had like a fruit bowl, you'd say I've got 5 apples, 3 oranges and stuff like that. So you just can group like things. All right, so here in that next example, they've got 7ab minus 6ab. So once the letters are the same, you just do the working out of the numbers. So you've got 7 minus 6. So that was 1. Now, do you remember yesterday we said we don't need to write the number 1. When you just have the letters there, it's assumed that there's a number 1 there. If you put it there, I will not mark you incorrect. You're not incorrect, so that's okay. All right, if we have, we're going to multiply algebraic terms. So here we're going to do multiply. You don't need to have like terms. You just simply put them all together. So if you say, for example, you had 2 times 8a, you times the 2 and the 8, which is 16, and you leave the a there. So in this next one here, when they have 6x and 3y, you can see they're multiplying the 6 and the 3, which is 18, and then they're just popping in those x and y into your answer. So the letters just remain there. Now, if you're dividing, so let's have I'll just write this one out again. So they had 8x over 2. So what we can do is you can cancel down like terms. So what do we mean? Because 8 could be actually 2 times 4 times x. So if I wrote that one out like that, so you can cancel down the same with top and bottom. So you can see why I'm just left with 4x, and that's why they get that. Okay, now remember division can be written like that, but when we have this scenario, we're going to change it to the fraction way. And just remember, I could write this as, because 6 could be the same as 3 times 2, and x squared is like saying x times x. So I've written like that, and I have 3 times x, sorry. And now I can cross top and bottom. So they cross out, and 1x can be crossed out with top and bottom. So you can see I'm left with a 2 and an x, and that's how I get 2x. So that might be a bit easier if you break it up like that, just until you get used to it. All right, so let's have a look at these examples. It says, write down the like terms in the following list. So in this list, is there a like term with 3x? No. What about 6a? Yeah. So we have 6a, what's its like term? Excellent. And what about, is there one with 2ax?
No.
Well, there actually is. This is the same. Why do you think I'm saying this is the same? They're the same letters, yeah? So it doesn't matter if you say AB or BA. It's actually the same because you're multiplying them. But why do you reckon they normally write it this way? Have a guess? So let's do this next one. What about here, up here? Is there a like term with negative 2ax? No, there's no other one the same. Okay, so let's have a look at the other one. What about this one? 3x squared a. Is there another one? Yeah, there. So we've got 3x squared a and negative 5x squared a are same. And what about what's left over? Are they similar? No. So all good. Pretty easy. We're just looking for like terms. Okay, so when they ask you to simplify, just means you're really going to calculate. You group the like terms and add them. So you're going to add the like terms, and then you leave if you can. Yeah. So first of all, we'll look, is any like terms in this expression? Yeah, good. 5a and 4a are like terms. So if I add 4 and 5, what do I get? 9. So I've got 9a. Now, the 3, you've got to keep it there because there was nothing else to add it with. There was no other constants or numbers, so we have to leave it there. All right, so if we look at this next one, we've got 3x and 5x. They're similar. And I could also say that 2y and negative 3y are similar. So what we might do when we get ones like this is first move it around so they're like next to each other. So we've got 3x plus 5x plus 2y minus 3y. Okay, we can add these ones because they're like terms. So what is 3x plus 5x? 8x, good. And what would be 2 minus 3? You've got 2 and you're minusing 3. Good, negative 1. So negative 1y. So I could write it like that, or you might see it written like this. Now with your negatives, if you're having trouble, remember maybe you might draw a little number line up the top. So say we had 0, 1, 2, 3 or whatever, negative 1, negative 2, negative 3. So just to practice, you were at 2 here and you wanted to go minus. So minus means you go that way. So 1, 2, 3. Okay? If you're a little bit like scratchy with that, just draw a little number line up the top and have a little go. You will get better once you do a few more. You get a bit more like confident, all right? Okay, let's look at this one. We've got 5xy. Do we have another 5xy? Yep, we do. And we also have these. Are these two the same? Yeah, they are. So I'm gonna first group them together, the like terms. And then I'm going to do them. So remember, I can do this. So what's 5 minus 2? 3. And so, yep, we leave the xy there. And what's 2? Now I'm going to say it's like plus 1, isn't it? Because there's one of them. So what's 2 plus another one of them? 3xy squared. Okay? We should start practicing putting a box around our final answer. It will help in the senior years when you're doing your exams. VCE examiners know that's your final decision. And also it can help me because sometimes if you're rushing and you've decided to change your answer, if you've boxed what you're saying is your final, then I know that's the one to take. Okay, so now we are up to multiplying. So remember that meant the timesing, algebraic terms. And we just do it like we normally do. So if I look at this first one, really you can times the numbers together. And so this is what it could look like. 2 times 7 times A times D. Now, can you do 2 times 7? Yep, that would be 14. And then you just do the A and the D. We don't need to have the times in between it. We just leave it like that. So up here in B, we're going to do -3 times 8 times M. And then I've got another M and an N. Okay, so when you've got a now we might need to write down on the side, we have to remember when we're multiplying. If we have a negative multiplied by a positive, we get a negative. If we have a negative multiplied by a negative, what do we get? Positive. So here I've got a negative multiplied by a positive, so I'm going to get a negative. I know it'll be a negative. So then what's 3 times 8? Good, 24. So then, does anyone know what happens when I write M times M? What does that, how? Excellent, well done. That means M squared. So I can write times M squared here times the N, because there's no other N's. So instead of having these multiplication symbols in there, I don't have to have them when I have letters, so I can just write it as M squared N. Don't worry, if your answer, you might have done it this way and you've written -24 N M squared, that's the same, that's okay, you're right. If the back of the book has it the other way and you're not sure, put your hand up and I'll make sure that and check for you. But you're most likely right, yeah? Doesn't matter which way the letter goes, we just often see it alphabetical order, okay? But if you didn't do it, you're not wrong. Okay, so then we're going down to the simplifying, and this is with the division. So what you want to do with the division is, because I can see a 6 on the bottom, I'm going to try and find, can 18 be a multiplication of 6? So can 6 times something be 18? Yes, and what is it? 3. Yeah, so we'll do 3 times 6 times x. So this little expression here is equal to 18x, isn't it? It's the same thing. And then I've got it over 6. So when you have the fraction line, you can cancel. So I can say there's 1 6 there and there's 1 6 there. So then you write what you're left with, and I'm left with, 3x. Okay, there was a 3 here and an x there. All right, so then over here on this next one, first I'm going to change it to divide like that. All right, and then I'm going to think about, can 8 go into 12 nice and even? No. Is there a number in 8 that also goes into 12? Yes, what is it? 4. So I'm going to change 12 to be 4 times 3, and I'm changing my a squared to be a times b. So I'm breaking it up there. And then down here, my 8 is the same as 4 times 2. And then I've got times A times B. Now I can cross out what's on the top and bottom. So there's one there. And I can also cross out an A. There's one A on the top and one A on the bottom. So then you write what's left. And if you have a look, I've got a 3A and a B. So 3AB. And on the bottom, yeah, good, works. So I ended up with 2B, but we're right, we can still cross these out. So I'll keep going. Now that I've done that, so my answer will be 3A over 2. Okay? All good. A rectangle's length is 3 times its width, which they're saying is x. So always when you get these worded questions, you should draw a diagram even if they don't have one, because it will help you. So I've got a rectangle, so I'm going to draw a rectangle. Okay? And they said its width to call x. So I'm going to call that its width and say x. And it said its length is 3 times its width. So what's 3 times x? Yeah, 3x. Okay. So the first question is they're asking for the perimeter of a rectangle. Now, what does perimeter mean? Does it? Yeah, good. So perimeter means you add the sides. Is that correct? Yeah. So if you look at our thing, this would also be an x, wouldn't it? And this would be 3x because it's a rectangle. They're both the same. So I'd go add them all up. That's how I find the perimeter. And then can I add them all up together? I can't I? Because they're all x's. So they're all like terms. So how many x's have I got there? I've got x plus 3x, which is 4, plus another one, 5, plus... So how many altogether? If you add all these up? 8. Excellent. There's 8 x's. So equals 8x. Okay, the next part, B, is they want the area of a rectangle. And who can remember how do we find the area of a rectangle? We do width times length, okay? Do you remember that? So then, in this example, the width is x and the length is 3x. Okay, so remember that's like a 1. So really what I'm saying here to do is like 1 times 3 times x times x. Yeah? So what's 1 times 3? And what happens when we have x times x? Good, x squared. And there's our answer. So you found, this is an expression here. Okay, you're finding an expression because it's written like that because you don't really know what x is. So that's an expression.